Good morning, dear students. My name is Marek Kucbel and I am from Technical University of Ostrava and from INET Center, where I work as a junior researcher. I and my colleague we have dealt with air pollution in the Moravian-Silesian region, and we have developed a new method for identification of emission sources in particulate meter. And of course we have dealt with the new method of the composting. We added the biochar to the compost, and of course with my colleagues we deal with new methods for identification of air pollution sources and emission in the Czech Republic. Of course, we have started using the drone for the measurement of air pollution, and we have now started using the drone for the detection of emission from landfill. But at the beginning, I would like to say that today I don't speak about emission from landfill, because this data is secret now, because we have prepared the new paper to the journal, and of course the technical report for our supporter. So it's not possible to say you more information about it. But you never mind. I will say a lot of words about the detection in the air where we use the drone. For this reason, I am start with it. At the beginning, I would like to say that the air is one of the most important components of environment. Yes, because you can choose the water, what can you drink? You can choose the food, what can you eat? But you don't have to choose the air, what can you breathe? Yeah? So, breath is an air is very important, and in the air we have a lot of pollutants. But today I would deal only with particulate meter, and the second parts I would deal with some chemical components in the particulate meter. It's mean organic carbon, element carbon, it's mean heavy metals and polycyclic aromatic hydrocarbons. But at the start we have to say some words about particulate meter. Yeah, the particulate meter it's mean the quality of the particle pollution, and the term of a mixture of solid particles and liquid droplets found in the air. Of course, the particle matter are suspended, yes, in the air. Some particles such as dust, soot or smoke and large of the dark enough to be seen with the naked eye, yeah, it's not problem. Other, the small, they can only be detected using the electron microscope. On the picture you can see the human hair and the detail of the particulate meter with diameter 2.5. Yeah, you can see here. And of course you can see the human hair and with particulate meter 10 with diameter 10 microns. Yeah, it means the aerodynamic diameter it's below 10 micrometer. From the comparing, you can see the fine beach sand, and this sand is probably 90 micrometers in diameter. Yeah. The particle pollution, its mean particulate meter, represents one of the critical parameters for monitoring of ambient air quality. Yeah, the effect of particle matter on health is summarized in the review. The size of suspended particles in the atmosphere varies over 4 orders of magnitude, from a few nanometers to 10 micrometer. Yeah, the largest particles it's called the coarse fraction or mode, and are mechanically produced by the break of the larger solid particles and release from construction, from demolition, from mining, and of course these particles can include the wind-blow dust from the agriculture processes, from uncovered soil, yeah, from unpaved roads, or the mining operation. The traffic produces road dust and air turbulence that can steer over this road dust. And my colleague Pavel today will speak about this street dust or road dust. Yeah. And of course, near the coast, evaporation of the sea spray can produce the larger particles too. The pollen grains, mold spores, and plant and insect are all in the larger size range. Yes, in the coarse mode is the typical representative of this mode. The amount of the energy required to break these particles into the smaller size increase as the size decrease, yeah, which effectively establish a lower limit for the production of these coarse particles of approximately 1 micrometer. The smaller particles, called the fine fraction or mode, and this fine fraction or mode are radiated from the gases. The smallest particle, less than 0.1 micrometer, are formed by the nucleation. Yeah, and it means that is the condensation of low vapor pressure substances from by the higher temperature vaporization or by chemical reaction in the atmosphere from new particles. The four major classes of the source with equilibrium pressure low enough to form nuclein mode particles. And of course, these nuclein mode particles is for typical the heavy metals vaporizate during the combustion. The element carbon from the carbon molecules generated by combustion, and organic carbon and sulfates and nitrates is the typical from the octane mode, nucleation and accumulation mode. Yeah, the particles in this nucleation range are or mode grow by coagulation. Of course, the smaller particle could be the bigger. Yeah. The typical in the nucleation mode, the starts this process, and the grow to the accumulation mode. The coagulation is most efficient for the larger numbers of particles, and condensation is most efficient for the larger surface area. Yeah, it's really important. And particles from the nuclein mode accumulate between 0.1 to 1 micrometer, and of course from this reason we can call the accumulation range. Okay, and now we will speak about the sources of particulate matter. The particulate matter could be divided into two main groups. Yeah, the one of this is the nature sources, and the second is anthropogenic sources. And the natural sources of particulate matter we could divide it into two groups. The one of these the group is the geogenic, and these geogenic particles it's come from the volcanic activity, from the forest fires, from the sea waves, sandstorms. And maybe you know that approximately 2/3 of the particulate matter comes from the natural sources. Yes, the natural sources is the bigger emitter of the particulate matter, and of course from these natural sources the main is from the sea waves. Yes, because sea waves produce a lot of the particles in the world, but these particles it's not danger. Yeah, because it's consists from the salts. Yeah, and it's the it is not from the combustion. The second, the group of the natural sources of particulate matter is the biogenic sources. Yes, this biogenic sources is represented by the biogenic material. It means the pollen, spores, and of course with microorganism. This microorganism is the virus and bacteria. Plant and animal residues, very small, yeah, residues, of course, uh, with aerodynamic diameter below 10 micrometer. Yeah, and this natural sources is very important too. And the second group of the particulate sources is represent the anthropogenic sources, and this anthropogenic sources is represented by the stationary sources, and this stationary sources, it's mean the residential heating, and residential heating is one of the most sources of particulate matter in the Czech Republic, and of course in the Poland and in the Europe, especially particles with a smaller diameter, yeah, with particle with 1 micrometer and below. Yes, it's the one of the main sources in particulate in the air. Of course, the residential heating have very special problems in Czech-Poland border, and we will deal about the details of this in our presentation later. And of course, the anthropogenic sources are represented by the power heating, by the incineration, by the chemical production, yes, mining activities, and of course with the energy sources. The second group, it represents the mobile sources. These mobile sources is not only about the automobile vehicle, but it's about the train, ship, yeah, by the airplane, by the non-road transport, and of course we can divide it, the group of the mobile sources, to the gasoline and diesel fraction, and of course the diesel fraction produce more particles than the gasoline. And the third group of the anthropogenic sources is the sources of indoor air pollution. Maybe you can be surprised, but a lot of the particles come from the household activities. Of course, the one of the bigger polluter is the vacuum cleaner, yeah, and vacuuming from the floor or sweeping. And of course, when you use the iron and ironing your clothes, of course, you produce a lot of particles. The particles, of course, produced by the cooking and prepare the meal, yes, on the boiler or on the cooker. Sorry. Of course, when you make a bed, or it's mean shake with duvet or with pillow, you produce a lot of particles too. And of course, from textiles release very small particles of PM10 and a little bigger sometimes, yeah. But you can see to these particles is not very danger for the human health, yes, except the smoking, yeah, because smoking is very danger. But this particle from textile and from vacuuming, it's typical not be Very danger. Of course, you can see or you can say me that from vacuuming is danger. Yeah, I agree, because there are the pollen and virus, so it could be. But from textile, it's not danger for human health. Yeah. And in this graph, you can see the production of particulate matter from the home working. I said household working. It's been sweeping, vacuuming, and from the shaping of the shaking of the duvet. So, at the first part, from 12 to 12 to 12:30, it is the production of particulate matter. When you make a bed, yeah, it means the shake with the duvet or pillow. You can see that the total amount of particulate matter is represented below 400 micrograms per cubic meter. The next process, it is the sweeping, yes, sweeping from the floor. You can see that the sweeping is the higher emitter of particulate matter in our home. And the concentration, the total amount of particulate matter represent 2,500 micrograms per cubic meter. And of course, when we compare with vacuuming, and vacuuming start with 12:45 to 13, and you can see when you start the vacuuming, the concentration is grow up to the 1000 micrograms per cubic meter, but then very decrease quickly, and about 15 minutes the concentration decrease to 50 micrograms per cubic meter. So on this part, you can see the concentration in the home area after these processes, and the typical concentration was approximately 20 micrograms per cubic meter after 30 minutes. Yeah, it will be stable of the air. So I don't say you don't sweep or vacuuming, but you can show this picture your parents, and you can say, "Mother, I cannot sweeping, because when I will be sweeping, when I will be sweep, I produce a lot of particles, yeah, and release a lot of particles to the air." So it is a joke. Of course, you you cleaning your room. Okay, and I start with residential heating before, and now I go back to the residential heating, because residential heating, I said, it's one of the most important sources of particulate matter in our air. And the reason why the concentration from the residential heating is higher is because the people use poor quality of the fuel. It's one of the reasons. And secondary reason is because a lot of people in the Czech Republic, and of course in the Poland, especially in this border part, use the waste for the residential heating. Yeah, it's the big problem, because they use the plastic, they use the furnished carpet, and many other wasted, and of course you can possible, because these particles, these materials could be combusted, but of course when we compare the incineration and residential heating, the concentration is more 100,000 higher. And of course it's more dangerous, yeah, because in incineration there are filter and cleaning system, but in the residential heating there are any filter or cleaning system. So a lot of particles with very danger composition release to the air. Yeah, it's emitted the chloride, the water organic compounds, and very danger compounds of organic matter. Yeah. The benzofurans, the benzodioxides, and many other. So, in this reason, it's necessary you don't use the waste in the residential heating. In our research, we deal with it and we identify the residues of the wasted material in the residential heating after they combusted the traditional fuel, it means the coal biomass. We added the amount of the plastic or any waste, and we deal with identification of the special markers. Yeah, and we prepare with our colleague the bigger table with this maker and the composition of this material in the char or in the ash from the boiler. Yeah, it's one of the very important for the identification and for the future in our act. Yeah, because in our legislation system, because we have start with the control of boiler and we need some instrument for this control. Yeah, of course we don't use only this char and ash, and we have start with the measure with the drone, but there are very special problems and I will speak about this, but it's one of the possibility too. And of course, the particulate meter could be divided into the primary and secondary particulate meter. Yeah, the primary particulate meter, it's represent the particles who are directly emitted into the atmosphere. Yeah, it's directly from the chimney, from the vehicle exhaust, and many other processes. Yeah, and the secondary particulate meter are formed in the atmosphere by the oxidation and reaction with the primary air pollutants. It means the particulate meter with secondary contributor or substances. Yes, with the gases. Yeah, the particles react with the gases, and these gases could be nitrogen dioxide, sulfur dioxide, ammonia. Yeah, and of course with volatile organic carbon, and these pollutants react with this particulate meter and produce the secondary organic matter. Okay, on this picture you can see the main sources of primary air pollutants. It's from EEA report, and you can see that how I said the residential heating is one of the higher emitter of the particulate meter, especially particulate meter 2.5, and it represents 53% of the primary air pollutants. And of course, when you compare with industrial and power heating, you can see that it's represented only 22% of PM 2.5. Yeah, but a lot of people said that the industry is the main sources of the particulate meter in the air, but you can see it's not true. Yeah, in the residential heating it's more dangerous, of human health. Okay, and now some words about the composition of particulate matter. The chemistry is very complicated because the particle formation is depend on the other pollutants and atmospheric conditions, of course, too. And in the particulate matter, we can found a lot of compounds because the particulate matter have the bigger surface area, and from this area could be absorbed a lot of contaminants. Yeah, it could be the polycyclic aromatic hydrocarbons, and of course it could be heavy metals, and of course it could be many other, could be potassium, sodium, yeah, and of course it's not very dangerous for human health, but it could be, yeah, and of course the particulate matter consists approximately from 10 to 50% by the carbonaceous material and with carbon, yeah, and this carbonaceous material could be divided into the element carbon and organic carbon. This is one of the main parts of the particulate matter. And of course, this particulate matter could be react with the secondary reaction, yeah, gas and aerosol with chemical conversions, and of course with sulfur dioxide produce the sulfates, the react between the nitrogen dioxide and particulate matter, this precursor, it's produce the nitrates, and ammonia react to the ammonium, and of course we can produce by the secondary aerosols the organic aerosols, yes, and this organic aerosols, secondary organic aerosols, which react with the volatile organic carbon and particulate matter, yeah. And chemical composition is the very changeable, yeah, and of course it's change during the time, during the place, and of course it's very composition of particulate matter from combustion process will be different when we compare with the particles when you compare with particles from the mechanical, from the mining, and from the agriculture, yeah. So and of course secondary particles and organic aerosols also affect the health, materials, agriculture, and the environment too. And particulate matter, of course, the most common and also the most important way to the entry particulate matter to the human body is inhalation, yeah. But of course it's not only about inhalation or by the breathing, it's respiration, but of course the particles could be entry by the orally, by the mouth, because when you eat something or food or drink water, you can entry the particulate matter to your body. And of course by the transdermally it's not very typical, but of course how I said, the particulate matter are consist with microorganism, yeah, which is the virus, bacteria, and this could be transferred to the body by transdermal way, yeah. So it's very important too. And of course, the size of particles is directly linked of their potential causing health problems. Yeah, The smaller particles below 10 micrometer in diameter, it's more the greatest problem because they can get deep into your lungs and some may even to your bloodstream. Of course, there we speak about very smaller particles. It's about from ultrafine mode. Yeah. And exposure of these particles can affect both of the lungs and your heart. And numerous scientific studies have linked particle pollution exposure to a variety of problems. Yes, it's premature death in people with the heart or lung disease. Of course, there are problems with lung function, and of course increase the respiratory system and irritation the airways. And of course the people with heart or lung disease, children and older adults are the most likely to be affected by the particle pollution exposure. Yeah. And of course, the particulate meter was classified by the International Agency of Research on Cancer as carcinogenic to the humans. It's group 1. And of course, the ambient air pollution and particulate meter cause adverse human health effects. Yes, it's including respiratory illnesses, cardiovascular disease, myocardial infarction, hypertension, atherosclerosis, its carcinogenic effect, ischemic stroke. Yeah, there are problems with adverse to the asthma, and of course adverse the diabetes and shortens life expectancy. And one of the problem is that the children in the industrial Ostrava conurbation had the high incidence of the acute illnesses and allergies compared with the children from the other parts of the Czech Republic. And sometimes you can see the research about the psychological impact from the air pollution. Yes, it's not very typical because a lot of scientists deal only with illnesses from this particulate meter. But of course, the psychological impacts is very important too, because because it's reduce subjective well-being, yeah, cause anxiety and depression and depression and even increase suicide risk too. Yes, so sometimes could be very dangerous from this reason too. By the other hand, the particulate meter caused the environmental problems. Yeah, of course, the environmental damage, the particles could be carried over long distance by wind, and of course, the settle of the ground of the water. And depending of their chemical composition and their size, the effect of this setting may include the making lakes and stream acid, depleting the nutrient in the soils, affecting the diversity of ecosystem, and contributing to the acid rain effect. Of course, this particle cause damage the material and can stain and damage stone and other material, including the culturally important objects such as statues and monuments. Of course, too, we cannot pass this part. And of course, the particles have visibility impairment. The fine particles are the main cause of the reduced visibility. Yes, because it's caused the haze in the part of the air. Yeah, And of course, the haze is caused when the sunlight encounters tiny pollution particles in the air. Yes, and the visibility is a big problem, and sometimes could be very long time. But of course, we have a lot of possibilities. How can we reduce the particulate matter? Not only in the primary sources by the cleaning system, yeah, by the filter and many other apartments. But we can use the natural sources, yeah, the natural, because the trees are very important in the city, and it's very important for the fight with particulate matter, because the trees reduce the dust and concentration of carbon dioxide and sulfur dioxide too. Of course, increased the humidity, produce the oxygen, provides a sustainable refuge for animals, and of course, trees can be absorb the small particulate matter, yeah, from the air. It's very necessary have two trees near from the road, yeah, because can be absorbed these particles from these sources. And very useful trees, or you can see on this picture, and I think so. It's very effective air filter. Yeah, the efficiency is very higher from this type of the trees. And when I start with concretely research and our results, it's necessary to say some words about origin and movement of the air pollutants. Yeah, from the chimney, from the vehicle exhaust, it's produced the emission. Yeah, the emission sources. It's concretely from this source. Yeah, from the chimney, from the vehicle exhaust, or from the chimney of the residential heating from the household or the house, and of course from power plant, and this chimney could be from the chemical industry and many other from metallurgical. Yeah, but it's the from the concretely. But when is the emission flow to the air, it's mean the air pollution. Yeah, it's air pollution, where the particles deposed to the surface on the to the surface. It means the deposition. And of course, the particles could be react in the air and with the secondary precursors. Yes, we told about this, and it's mean the transmission. Yeah, the transmission, because it's changed the chemical composition, and of course the transmission is not only about the chemical changes of particles, but could be associated with the move air from the another parts. Yeah. So for determination particulate matter from the air, we can use a lot of the measuring equipment. There you can see the standard methods. What can we use in the Czech Republic? Its measuring equipment consists with not only with measurement for particulate matter, but it's the second parts or pollutants in the air. Yeah, there are devices for the determination of sulfur dioxide, for carbon dioxide, and for ozone, and many other pollutants in the air. So we can you can use the traditional measurements, and you can use the automatic air pollution system. Of course, we can use in this time the mobile station, as you can see on the picture here. There are many options for use, and many air sampler you can use. Yeah, for PM sampling, usually we use the low and high volume sampler. Yeah, the system of the high volume sampler you can see on the this on this scheme. Yeah, the particles come from this area and through the sampler there are the filter where is the particles are collected. Yeah, and the air it's exhaust outside of this sampler. Higher volume sampler, it means use high volume. It's approximately 10 cubic meter. When we compare with low, it's approximately 1.4 cubic meter. Yeah, use this this so typical for the determination of particulate meter is filter based of gravimetric sampling. So at the beginning you have the pure filter. Yeah, you must be equilibrate, and you must weight this filter. Then you use the sampling, and after the sampling you post weighting. Yes, so you must equilibrate post weight, and of course your calculation you use concentration post weighting minus pre weighting. Yes, and multiply by the volume. Yeah, and you use the mass concentration of particle matter. So on this slide you can see the picture of the filters from a low volume in the Moravian-Silesian region. It's concretely you can see the different darkness of this filter. It's not and it's associated with the sources, yes, of this particle. In Carvina, it's the darkness, the filter. Its particles comes from the particles come from combustion processes. Yeah, there are a lot of combustion processes. When we compare with Karlova Studenka, it is the area in the mountain, and of course the air is more cleaner when we compare in Karvina, which represent urban industrial area. Okay, but in our research we don't use only the traditional measurement system, but we use the modern instrument. Yeah, in this reason we have both the LP plus. It means the electrical low pressure impactor, and it's very useful for the identification of particulate meter from individual particle size. Yeah, because it's enable measurement of real-time particle size distribution and concentration in the size from the 6 nanometer to 10 micrometer. Yeah, so we have from the ultrafine mode to the coarse mode. Yeah, from the octane to the coarse mode, and it's very useful for identification of the sources. Yeah, because the LP plus can be used not only for gravimetric measurement but could be used for the chemical analysis, and we have used this device for the identification of heavy metals. And of course, the foils from this impactor could be used for the electron microscopy, and you can identify the particles by the optical methods. Yeah, on this picture you can see the scheme of the LP impactor. There are the 13 impactor stage operating in range from the 17 nanometer to 10 micrometer. Maybe you can you can agree with me, because I said that they're measured from 6 nanometer. Yeah, it's possible, but this 6 nanometer is in the filter stage, and in this filter stage there are no foil for this particles, but it could be measured only by the calculation of devices. Yeah, but practically we have start with 17 nanometer particles. This is the first stage. What can we use? For the chemical analysis? And of course, on the top there are the precipitator, and these particles with diameter higher than 10 micrometer, and we don't use it. Yeah. So we use from the 10 micrometer to 17 nanometer. And of course the particles are different. Yeah, there are the different particles and different sources of these particles. It's the combustion process, nucleation modes. Yeah, we speak about this at the beginning of my presentation. On this slide, you can see the differences between the particle collection to the individual impactor stage, and of course you can see the size of the particles. Of course, it's not a real size, because the particles collect 1 to 1, yeah, and of course the shape of this impactor stage it's different. Yes, it's one of the reasons is because the collect can separate the particulate meter. So, and now I would like to say some words about the size distribution of particulate meters in the urban of the Moravian Silesian region. And from this region, we have used 10 localities, and these localities were divided into 4 groups based of the mineralogical analysis and of the total dust deposition. Yes, the content of the hematite and magnetite. The distribution of the localities was the first group, and it was localities significant affected by the metallurgical industry. It's typical from the Ostrava Radvanice, from the Třinec and Třinec Oldřichovice. And of course the localities affected by the metallurgical industry, the smaller part. Yeah, so it was locality 4, 5 and 6. It's been Ostrava Mariánské Hory, Havířov and Frýdek Místek. And the localities less significant affected by the metallurgical industry is locality Karviná and Ostravice, and localities without significant affected by the metallurgical industry, it's Ostrava Poruba and Hradec nad Moravicí. Maybe we can be surprised that Ostravice it's affected by metallurgical industry. Only small amounts of these particles come from the metallurgical, but of course it comes by the wind from the Třinec or from the Ostrava. Yeah, so I said the air is not known about the border. Yeah, the air is without the border. Okay, on this slide you can see the distribution of particulate matter during the summer season. And during the summer, the distribution of the mass concentration of particles was very variable. Yeah, the pronounced bimodal nature in the coarse grain class, about 4 micrometer, was demonstrated in the localities Frýdek Místek, Karviná, and Třinec. And in the localities of Třinec, Oldřichovice, and Hradec nad Moravicí, there were no significant peak concentration of particles in the fine grain class. The localities of Ostrava Radvanice and Ostrava Mariánské hory, Ostrava Poruba and Ostravice reflect the multimodal character of the size distribution in the particle size classes. Unimodal character of the distribution of particles was only shown in the Havířov. In the transitional seasons between winter and summer seasons, represents from September to November. The 7 of the 10 localities have the bimodal distribution of the mass concentration of PM. Yeah. The main peak in all 7 localities range from the 156 to 614 nanometer. Approximately more than 50% of these particles can be found still in this range. And the second less significant peak is represented by the coarse particles ranging from 2.4 to 4 micrometer. It represents approximately 7 to 15%, and the highest concentration of particles of 7 location found in the classes 263 to 383 nanometer. Yeah, the locality of Ostrava Poruba is characterized by the 3 model data layout with the main peaks. Yeah. In the range 156 to 263 nanometer. Only 18% of the total number of particles represent in this range of particles. And 383 to 613 nanometer is represent 70%. And the third peak in Ostrava Poruba was for the size of 4 micrometer, and it represents approximately 5%. And the locality of Ostrava Mariánské hory is characterized by the multimodal particle distribution too. And for the locality of the Třinec Oldřichovice, there are no significant concentration in any particle size. Yeah, it was not detected. You can see that can be not multimodal. It's hard to say about this distribution. During the winter season, the 8 of the 10 sites showed a significant unimodal distribution of the mass concentration of particulate matter, with a peak in the range 263 to 949 nanometer. Yeah, the unimodal distribution of particles was found in Frýdek Místek and Ostrava Mariánské hory, and in the interval from the 263 to 949 nanometer, more than 54% of the total amount of particles are presented. Yeah, the highest concentration of particles in the class 263 to 383 nanometer was found in the locality of Havířov, Karviná, Ostravice, Ostrava Poruba, and Hradec nad Moravicí. In the localities of the Ostrava Radvanice, Třinec, and Třinec Oldřichovice, the highest concentration of particles was detected in the class from the 383 to 614 nanometer. The locality of Ostrava Mariánské Hory and shows no trends. And it is the locality of Frýdek Místek, a significant biomodal character of particle size distribution with peaks in the class of 156 to 263 nanometer and 363 to 614 nanometer was found. So, in the winter period, unimodal distribution of dust particles was demonstrated with a maximum in the class of 263 to 614 nanometer. And in the 5 localities, the maximum concentration was found in this in class of 263 to 383 nanometer. And highest concentration was found in this class, yeah. And of course, there are no relationship between the particle size distribution and pollution that come from the metallurgical industry. Yeah, it was not proven. And about the presence of hematite and magnetite in these localities, because we use this for the divided the groups, I can miss the information about it. Yeah, because in the 8 localities was found the presence of the hematite and the sampling sites with significant load by the particles from metallurgical include the Ostrava Radvanica, Třinec Oldřichovice, Havířov, Ostrava Mariánské Hory and Karviná. And the percentage of the secondary minerals in the higher during the winter than in the summertime, with exception of the sampling site of Ostrava Mariánské Hory. Compared with the winter season, the percentage of the resuspended particles is from 1.2 to 7.5 times higher in the summer period. In the average content of resuspended particles in total suspended particles, it's approximately 21% for the all 3 sample period and all sampling sites. The lowest concentration of resuspended particles were found for the sampling site Třinec and Havířov. Yeah, so it's reason for the determination of the hematite and mineralogical composition of particles in these localities. Okay, and now I would like to deal with another part of our research, and I would like to say some words about the water soluble ions in the individual particle size. At the beginning, the sampling of PM was performed from the period 18th January to 31st March of 2016 in the city part of Ostrava Poruba. And the point of view, the air quality Ostrava Poruba is urban quarter, which belongs the least polluted parts of the city of Ostrava. How you can see from this particle size distribution from the next from the slide before. Sorry. And the air quality in this area can be influenced by the transport. Yeah, the sampling site is located in the immediately neighborhood of the road crossing with the high traffic at the exit from the city of Ostrava, and of course with local heating and long distance transform from the industrial sources located in the Ostrava conurbation. And also transborder transport from the Poland, which is relatively near. And in this study, 18 samplings of the particles were performed, and time of the sampling of each sample was 96 hours. And during the sampling of the dust particles, the meteorological parameters were monitored too. It was concretely the temperature, wind direction, atmospheric pressure, wind speed, and air humidity. And of course, I would like set some words about these meteorological parameters on the next slides. So we could start with concentration of PM10. Range from the 11.2 to 34 micrograms per cubic meter, and average value was 20 micrograms per cubic meter, yeah, during the monitored period. For 16 from 18 samples of PM10 particle size class, the PM below 1 micrometer was represented in the range from 60 to 80% particles of the size, yeah. And of course, in the size from 1 micrometer to 10 micrometers, from by 21 to 30% of PM10. In the 10 cases, the most particles were concentrated in the interval from the 0.384 to 0.606 micrometer. And for 6 samplings, the highest concentration of particles was in the interval from 2.5 to 10 micrometer. Yeah. In the 2 cases, the percentage of the PM 384 and 606 nanometer and PM 2.5 to 10 was comparable, which can be explained by the low relative air humidity. On the in the picture in the right side, you can see the average content of the water-soluble ions in the particulate meter 10, and these water-soluble ions form 56% of PM10 during the entire monitor period. The potassium exhibited the highest average concentration of 13%. It's mean 2070 30 nanogram per cubic meter of PM10. And the lowest average percentage of water-soluble ions for individual particle size were found in the coarse grain particle size. It was 33%, and it was size classes from 2.5 to 10 micrometer. Yeah. And the highest percentage of water-soluble ions were determined for the particles from 156 to 258 nanometer. It's approximately 62%. The average concentration of water-soluble ions in individual particle size classes are illustrated from this picture. Yeah. How I said at the beginning, the meteorological conditions play a very important role in the distribution of particulate matter and water-soluble ions. The most critical parameters are the wind speed, temperature, and relative humidity of the air. The significant negative correlation between wind speed and concentration of water-soluble ions in PM10 indicates in the prevalence of the local pollution sources. The inverse proportional between fine-grained particles and relative air humidity suggests that the relative humidity can remove atmospheric particles and decrease the amount of the resuspension soil dust. The meteorological parameters have considerable influence to the origin of the individual water-soluble ions, and the lowest concentration of the SUM of PM10 in Ostrava Porba were observed when the temperature were the highest simultaneously with the lowest values of the air humidity. The highest concentration of PM below 1 micrometer were found during the lowest wind speed. And the highest concentration of nitrates, sulfates and ammonium and the total sum of all monitored water-soluble ions in PM were observed when the air humidity was the highest. And this relationship is not valid for the nitrates, where the highest concentration of nitrates do not correspond with the highest air humidity. And the number of emission sources from the local heating increased with decreasing of the air temperature that is connected with an increase of concentration of sulfates, nitrates and ammonium and particles of the size below PM1. And of course the coloration coefficients were found between the individual ions and temperature. It was negative and confirmed that fact that with increasing temperature decrease the amount of individual ions and vice versa. And the decreased temperature in the winter can facilitate transformation of gases, nitric acid, in the particles phase and origin of the nitrates. The relationship between sulfates, chlorides and ammonium is documented by the forming of the mixed crystal in this picture. Because in Ostrava the relationship between these ions were significant, in particular from 600 nanometer to 2.5 micrometer. And it increased air humidity, the concentration of PM, and the sum of the air of the water-soluble ions are increasing too, how I said. And the highest concentration of the most ions were determined from the northwest and north-northwest and southwest direction of the wind, how you can see on this picture. And of course, this concentration of ions is related to the influence of emission sources in bordering Poland, and southern and southwest direction of the air flowing bring the air mass passing through the depression of the Moravian Gate. And the high enrichment factors of sodium, potassium and chlorides are related in the iron and steel industry from the metallurgical industry in Ostrava. Because in Ostrava there are situated very high proportional of metallurgical industry in the Czech Republic. And the chemical character of the emission contain up to 50% of chlorides. It's mean sylvite, halide, and it was changed after the introduction of dust removal using back filters. and the high concentration of chlorides in the ambient air have the relationship with wind direction from the metallurgical industry in Ostrava, situated in this southwest. So to conclude from this part of our research, I would like to say that the average content of inorganic water-soluble ions in PM was 56%, and the highest average percentage was represented by potassium. Its origin from the combustion of biomass and coal, but it's also connected with the metallurgical industry. And the concentration of water-soluble ions in different grain size of the PM increased with a decreasing temperature. And of course, very important is that the majority of particulate matter samples are significantly higher percentage for PM below 1 micrometer. When we compare with particulate matter over 1 micrometer. Yeah, there are the predominance of anthropogenic sources of combustion over natural sources. Okay, the air quality, not only in the Czech Republic, especially in the more Moravian region, but also in the Europe, has been improved significantly over the previous decades. Nevertheless, the air pollution is still a large environmental health risk problem. The Ostrava-Karviná conurbation, representing the part of the Ostrava basin and considered one of the most polluted area in the European Union, and it's due to high concentration of the most significant air pollutants, predominantly by particulate matter, and high concentration of benzoapyrene. And in this reason, we have focused about the information of the changes in the chemical composition of water-soluble ions, trace elements, and forms of the carbon occurrence in the relationship on the direction of air flowing and concentration of PM10 between the acceptable and exceeded pollution. The acceptable and exceeded pollution was divided decide on the concentration of PM10, and concentration it means that yes, that the winter season and smoke episode were divided using 24-hour air concentration limit valid for the PM10. It's mean 50 micrograms per cubic meter according to the Act of Air Pollution in the Czech Republic 201 2012 collection, and of course from the Directive 2008 50 EC of the European Parliament and the Council of the European Union about the ambient air quality and cleaner air for the Europe. Yeah, and of course the concentration of PM10 over 50 micrograms per cubic meter are designed at the period of the exceeded pollution, and period with the concentration of PM below 50 micrograms per cubic meter, it is represent the period with acceptable pollution. And about this reason, I would like to say some words about PM10 and legislation, because in the Czech Republic the smog situation is declared under the Air Protection Act 201 2012 collection, and it's mean when it's the parameter of PM10 exceed pollution 200 micrograms per cubic meter by 12-hour period. Yeah, of course it's definite for the other pollutants, but I would like to say about only PM10. but nevertheless, in the Europe does not specify the value for the determining the smoke condition based on the concentration of PM10. Yeah, it is the missing information. And in the Poland, the situation was a little different because the last year you have received the new parameter for the smog, because before you have maybe you have 300 micrograms per cubic meter for the smog situation, but now you have the similar as in the Czech Republic, and it is 100 micrograms per cubic meter, but not only 12 period, but 24-hour period. And of course, the Moravian-Silesian region, and not only Moravian-Silesian region, but the Upper Silesian region in the Poland. It means the Malopolska regions. There are the same situation. Yes, what can we found in Ostrava? This region, you know, it's located in the southern part of Poland, and it is the near for the border with the Czech Republic. And of course, the Malopolska region is one of the most polluted region in the Europe. Yeah, and poor air quality is caused by the extensive concentration of PM10. So I said it's the same and in our country, or especially in Moravian-Silesian region. And this region is influenced by the local pollution. Yes, more influenced by local pollution when we compare with long-range transport or regional transport. And the primary pollution sources of PM10 in the area of Polish and Czech border between Ostrava and Katowice, it is the residential heating. Yeah. And during the years 2006 to 2012, the PM10 daily transport was more significant from the direction of Poland to the Czech Republic. And the most important emission source of particulate matter in Poland are the so-called the low emission. The low emission, it's represent high up to 40 meter, and residential boiler and traffic pollution. Yes, and I would like said that this part deal with comparing between the Czech and little about the Polish concentration of PM10 and water soluble. The sampling size was a little different when we compare with the research before, because we deal only 8 localities, and these 8 localities were selected with the influence of various emission sources. And in these localities you can divide it with localities influenced by industry. It was locality in Ostrava. It was Ostrava Radvanice, Ostrava Mariánské Hory, and Ostrava Radvanice nad obcí Ozo. And of course we have the Ostrava Poruba. It is the typical urban area without industrial influence. And then we have the Studenka and Dolní Lhota, Věřňovice, and Mosty u Českého Těšina. That is represent localities with residential heating. And this sites you can see on this map, and there are the details of the industry in Ostrava and in Moravian-Silesian region. And of course there are mentioned part of the Poland. At the beginning, I need to say that the concentration of PM10 was degrees when we compare the year 2019 with 2010. Yeah, the degrees is very valuable, and of course it was influenced by the winter, because the winter is not very cold. Yes, it's little difference between winter in 2010 and winter in this time, yeah, because it was the higher temperature, and local heating was degrees, and of course a lot of boilers in the Czech Republic was changed to the new, and of course it influenced or it could cause the degrees of the concentration of PM10. But when we see to the concentration of PM10, you can see that the PM10 in the period of the acceptable pollution was 33 micrograms per cubic meter, and increased 2.8 times during the period of exceeded pollution, and average concentration reached to the 93 micrograms per cubic meter. And the highest average concentration of PM10 during the period of the exceed pollution was determined in the Mosty u Českého Těšína, and it was 130 micrograms per cubic meter, and the lowest was found in Dolní Lhota, and it was 70. Yes, but we speak about exceeded pollution. And the content of ammonium ions and organic matter and PM10 increased significantly during the exceeded pollution. Yeah. Okay, because we don't have a lot of time, I change my slide and come to the enrichment factor from the trace elements, because it's really important, because extremely enrichment factor was found for cadmium, which is approximately 100 times higher when we compare with locality in the Prague. And big problem is with the copper or zinc or lead, because it was 100 times higher compared of the background locality Košetice in the Czech Republic. Yes, so in these localities we have little influence, very high influence by the metallurgical industry, and it's of course represent approximately the metallurgical industry represent approximately 10 to 20% of PM in the Moravian Silesian region, or especially in the Ostrava. And about meteorological conditions and which direction, I said that the temperature, humidity, and wind speed and direction is very important for the concentration of water-soluble ions, and generally during the predominantly good dispersion condition, the pollutants are usually transported from the Czech Republic into the Poland. By the other hand, during the worst dispersion condition, it is the opposite. Yeah, so it's a little problem, because we have produced a lot of concentration of PM, and this concentration are more higher due to the concentration from the Poland. In the most localities, in the case of the airflow from Poland, the amount of water-soluble ions decreased by 13%, and the content of the odors and the suspension particles, amorphous fly ash particles based on silicate and iron rich oxide matrix, it's by 7%. Yeah, and element carbon content increased by 1% and organic matter content by 15%. Very important is enrichment of the chlorides, sulfates, and ammonium ions and nitrates. It's the case of the air flow from the Poland is related to the combustion of the fossil fuel. Yeah, it's not from the industry, but especially it's from the local heating. And now I would like to say some words about carbonaceous material, because how I said, the carbonaceous material represent a very important part of the particulate matter. It represents approximately 10 to 50% of PM. And of course, this carbonaceous material could be divided into the element and organic carbon. Yeah, and element carbon, it is only a product of incomplete combustion processes from biomass and from coal, and of course from the vehicles. Yeah, but it's only primary production. Yes, it's come from the primary production. On the other hand, the organic carbon it is the primary product of the combustion of incomplete combustion processes as element carbon. By the other hand, the organic carbon could be produced by the secondary reaction in the atmosphere, especially by the reaction with oxidation and water organic compounds, yes, and this produce the secondary organic carbon. And of course, so organic and element carbon is very important part of particulate matter. But now I would like to say some words about black carbon, because black carbon, it's a little similar, same definition for the element carbon. Yes, it is the product of the incomplete combustion of fossil fuels, biofuels, and biomass. And of course, the black carbon and element carbon have the similar chemical structure, but of course there are some differences. We don't have a lot of time for explain more details about it, but I would like to say that there are the convention that the black carbon is determined by optical method. By the other hand, the element carbon is determined by thermo-optical method. Both black carbon and element carbon strongly light absorbing component of particulate matter. Yeah, because can absorb the light and can heater the atmosphere. And these particles are very smaller. They have a very small size from 0.0001 micrometers. Yes, it's approximately 1 nanometer, but it's condensate and aggregate to the particles larger size. Yeah, to the 0.1 to 1 micrometer, and it's very important part of particulate matter below 1 micrometer. Yeah. It's very important, and of course can have influence Earth climate, and of course they have a very harmful effect to the human health. Yes, because can absorb the heavy metals, polycyclic aromatic hydrocarbons, and of course it's similar with particulate matter, because it is represent the problem in the particulate matter too. And for the study of black carbon, we have used ethylometer, and this ethylometer we have used in Ostrava, concretely in Ostrava Zábřeh. We have started measurement in 2012, and we continue to this day. But in this part, I show you the older data because the new data we prepare and we finish the paper, so it's not possible to show you this data. But the sampling was represented in the urban area, yes, and it was influenced by industry. Exactly, and of course there are a lot of block of flats, and there are a smaller part of local heating, but local heating it's situated very near from this area. In the beginning, we have started with geochemical background value of black carbon, and for the Moravian Silesian region, it is the 0.2 micrograms per cubic meter, and it was measured in a mountain area in Beskid Mountains. And the geochemical background value for Ostrava Zábřeh, it was 2.7 micrograms per cubic meter. This concentration is typical, and it's little higher when we compare with another clean part of the Czech Republic, and of course it is typical value for the industry town in the Europe. But the main problem with black carbon, of course, it's not about average concentration, because average concentration is approximately same when we compare with European cities. Of course, you can see the concentration of PM10. You can see that in the 2015 was lower when we compare with 2013. But the main problem with black carbon is during the heating season. Yes, because during the heating season the concentration are more higher, and of course not only concentration of black carbon but concentration PM10 too. You can see that in the January and February the concentration decrease 3 or 4 times when we compare with the summer concentration. Yeah, so in this picture you can see this concentration of PM10 and black carbon, and of course you can see that the variability is the same year to year, month to month. Of course there are some small differences, but the behavior is the same. On the year to year, yeah, the average concentration of black carbon increased to 10% from 3.3 micrograms per cubic meter in 2012 to 3.66 microgram per cubic meter in 2014. But if you see the average concentration, you can see that the problem is the January, February, and December, and it's the connected with local heating. The concentration during the spring, especially in the May and June and July, the concentration are the lowest. When we compare the concentration during the heating season and non-heating season, you can see that the concentration it's approximately 3.5 times higher during the heating season when we compare with non-heating season as an influence by residential heating. So it's very important for our research because when we compare the summer concentration, where is the industry production only, we can see that the concentration not very high. Yeah, it's approximately about 1 micrograms per cubic meter. Of course, is associated with meteorological parameter, yes, with wind speed and with rain, and of course, and I agree with this. But of course, there is explain and to confirm that the residential heating has the higher proportional of the PM and of course to the black carbon concentration. When we deal with weekly distribution of black carbon and PM10, we have found that the concentration of black carbon and PM10 during the working days were 3.344 micrograms per cubic meter for black carbon and 47 micrograms per cubic meter for PM10. Yes, only on the Sunday the concentration was a little lower. When we compare the morning and evening concentration of black carbon, the morning concentration were monitored in the period from the 1st September to 31st December, and it was found that the average evening black concentration is only about 0.11 microgram per cubic meter higher than in the morning. So concentration during the morning and evening time it's comparable. Yeah. And there are not found very big differences because it's influenced by the same sources. It was the traffic and residential heating, because the peak is in the morning and in the evening when the people come back from the work. Yeah, and morning comes to the work. So in this the reason there are not very differences between the concentration. And we have found very significant correlation coefficient between PM10 and black carbon, and it represents very strong or significant during the whole period. It was 0.82. And of course, this coloration coefficient between PM10 and black carbon is more higher during the winter time, and during the summertime is the lower. And it is the reason because the PM10 it's consists not only from carbonaceous material from the combustion processes, from the power heating, chemical industry, metallurgical industry, and of course from vehicles. By the other hand, in the summer times, a lot of the particles of PM10 it consists with biogenic. Yeah, it residues with virus, with pollen, and many other parts of biogenic sources. So, how I said, the black carbon concentration are influenced very strongly by meteorological parameter. Of course, increased concentration of black carbon is influenced by degrees of temperature. And of course, when the wind speed is higher, the concentration of black carbon is lower. And of course, the black carbon is influenced by the wind direction. The maximum black carbon concentration comes mainly from the northeastern or southeastern wind direction. The northeastern, it is from the Czech-Poland border. So this concentration comes from the Poland and southeastern. It is influenced by metallurgical industry. And the minimum measured concentration of black carbon, it's come from the west or southwest wind, and this direction is typical for the Moravian gate, and of course the concentration when the wind flow from the this gate is the lower concentration appear in the Ostrava. And very quickly to the end, I would like to say some word about unmanned aerial vehicle measurement. It means the drone measurement. With the drone, we use drone with flying laboratory, and this flying laboratory is from a Centroid company. And it is equipped by watts, ammonia, particulate meter, and so sulfur dioxide, nitrogen dioxide sensor with the detection limit. What can you see in the table? And of course, we have used the optical measurement for the particulate meter, and we can measure the particulate meter from PM1, PM 2.5, and PM10, and total suspended particles. We have used the drone for the flying laboratory, drone and flying laboratory to the sampling in the household with boiler of emission class 2 and 3, and now the boiler of emission class was changed by the emission class 5. And we have used different fuels, yes, with representing the biomass and coal, and of course we added the amount of the waste, approximately the plastic and many others. And of course, for the compare, we use the ash, and we use the char from the boiler. So for the measurement, we use the drone, the DJI Matrix 600 Pro Professional, and this drone is equipped by flying laboratory or measurement of particulate meter. It's represented by Fidas Frog from Palace company. Yeah, and then you can see there is the sampling from the boiler, and we are outside in the chimney, and we go to the smoke, and we have found the source of the particulate meter and many other pollutants, and of course we have to find the values what can be confirmed the typical fuel or typical waste. And of course we have to find how long the concentration of this pollutant could be emitted to the apron. So in this reason we have not measure only in the middle of the smoke, but we want to measure in the further parts from the chimney. For the measurement, we have found the ideal measuring set. This measuring set is represented by the drone DJI Matrix Pro and the smaller drone, the Phantom, and it is used for navigation to the chimney smoke, and of course the FIDAS Frog Palace for the measurement of particle meter is very useful, and of course for the determination and identification sources we have used the accelerometer. It is the small accelerometer what can we use in this drone. And for this measurement system we have used the water absorption, water organic carbon absorption tubes. It's very useful because these tubes can be analyzed in the laboratory, and we have found a lot of information about organic compounds in this from this measurement. In the drone measurement, there are a lot of legislation, prohibition, and of course a lot of problems with the measuring of the drone because in the Czech Republic it's prohibited flying near to 150 meters from the residential area, and of course it's not used the drone for this measurement. In Poland the situation is little different, of course the legislation is a little different, and in Poland, especially in Katowice, it is possible measure with drone and use flying laboratory for the identification emission sources from the residential heating, and in the Czech Republic it's not possible. Yeah, but the idea is and the best for the measurement with flying laboratory is the part, and it could be in the chimney smoke, and it will be distance from 50 centimeter from the chimney. And of course we have the length of the probe, it was 1 meter, but the distance, the 0.5 meter is the best, yeah, for the detection of the pollutants from the fuels combusted in the boiler. So there is the original planned measurement without legislation restriction. You can see the main drone with flying laboratory, the second drone for the cooperation of drone with flying laboratory, and of course for the recording of video and photo documentation. And of course it's necessary to have 2 pilots and 1 operator, because it's not time for the writing the notes when you are measure. So now I would like to say some picture from the real measurement with our drone. On this picture you can see the drone in the real measurement from the local heating. Yeah, you can see that we are from the distance 50 centimeter from the chimney, and in this we are approximately in the middle of the smoke. I would like to say that the measurement with the drone is not very easy because you have problem you have we have often problem with the wind speed, yeah, because it's very higher. It's not good to fly with drone, and of course the change the smoke direction, yeah, so it's very difficult, and the values of pollutant is not valuable, and it's not standard, yeah, and it's not possible make the standard value from the drone measurement. It could be only useful tools for the detection emission, but you have to do a real measurement, or you can go to the household, and of course you have to sample from the boiler. Yeah, you need the sample of ash or char from the boiler, and after these samples you can identify 100% of fuel who was burnt in the boiler. Yeah. Okay, there is the drone to the second boiler, the emission class 3. You can see that you don't see any smoke from this chimney. The chimney before, it was boiler from emission class 2. Okay, but when we added the plastic, you can see that the smoke is more visible, and it's more easier for the measurement in this smoke. And on this picture, you can see the drone, smaller drone, for the control the drone with flying laboratory. And of course, there are a very short video from the measurement. You can see how the turbulence wind direction influence the drone, and it's not very easy stay in the one place. Yeah. And one operator said to the second operator, you can move to the right, to the left, yeah, or up or down. So it's only small part, and of course I would like show you. Yeah, there are the drone again. The result for this measurement, of course, we have deal not only with the measurement of pollutants using by flying laboratory, but we have deal with air pollution and standard methods, and we have deal with the concentration of carbonaceous material, especially with organic carbon and element carbon, by the three devices, and you can see that the concentration was a little similar. So there you can see the differences between the concentration when we have combusted the spruce wood and PET bottles. Yeah, the boiler of the third emission class up to 136 times in the case of the boiler of the fifth emission class, up to 24 times increase in black carbon concentration. Yes, then when the burning only spruce wood without PET bottle. Yeah. And we have used for this measurement the accelerometer with the value for the UV channel, blue channel, green channel, red channel, and infrared channel. And infrared channel, it is represent concentration of black carbon. Yes, the real concentration of black carbon. But the another of these channels of accelerometer is very useful for identification of other sources of emission. Yeah, UV channel, it's typical for organic carbon. And of course, you can see the concentration when we have added the PET bottle, and without PET bottle, yeah, the concentration is very smaller. But when we have added the bottle, the concentration increased very quickly. But of course, very increased quickly and decreased very quickly. So identification is not very easy, because when the people see the drone, of course they have stopped. Put the waste, yeah, to the boiler. So in this reason, it's necessary use the standard methods and to use ashes from the boiler for the detection of the fuel. Yeah, but it's very useful tools, how I said. So utilization drone for the real measurement is a very good idea. By the other hand, there are a lot of problems. Yes, there are the legislation restriction. There are problems with turbulent airflow, and of course there are problems with with the meteorological parameters. Yeah, because there is prohibited flying during wind speed. It's more higher, 40 km/h. There are problems with the rain, of course, and of course you have you need the license for the measurement. It's not very easy to start, and it's the long process. And of course there are problems sometimes with communication between transmitter and drone, but it's the good idea in my opinion. Thank you very much for your attention. Sorry for my pronunciation in some part, and of course for my quick speak, but there are a lot of information and I missed a lot of information because we won't need the more time for this only air pollution and or our results from the Ostrava and Moravian Silesian region. But if you have any question, you can write me or you can ask me. So thank you very much, and I wish you a very nice day. Thank you.